Good evening. Welcome to Bzign Talks. Today, I will be speaking about the topic floating modular homes or amphibious homes using BIM. BIM Labs Engineering Services Private Limited. It is situated in Kerala, southern state of India. It is an Autodesk learning partner and member of IGBC, Indian Green Building Council. Our business areas are BIM training for students and corporates, BIM implementation support for corporates and organizations, BIM project outsourcing, BIM placement services. For more details, you can contact us through email, WhatsApp, Facebook, web, and LinkedIn through the displayed addresses. I'm Arya Shaji, Technical Engineer, BIM Labs Engineering Services Private Limited. You can contact me through mail on the displayed address and also through the LinkedIn address. Floating modular homes or amphibious homes using BIM. Floating and amphibious architecture has been around us for centuries, and there is a long tradition of such buildings in various parts of the world. But in recent years, technology and design ambitions have rapidly accelerated to meet changing climatic conditions. Among all architectural designs, as a resolution for flooding, the amphibious designs tends to be the most effective and the most resilient option. The concept of amphibious house is adopted in which it refers to the structures that will function both in land and water in response to flood in low-lying areas. This configuration allows the houses to rise with the flood water, mitigating the damage caused by the seasonal flooding. Agenda: amphibious homes, basic principle, component parts of floating homes, building information modeling, then BIM workflow. Amphibious homes. Amphibious homes are structures constructed in a place where frequent flood occurs. The design, planning, and construction of flood-resistant structures differ from place to place based on the various factors such as determination of flood characteristics, identification of source, nature, and severity of flood hazards, etc. The selections of flood damage resistant materials are also very crucial. The construction and design allows the house to float on the flood waters when the water level rises. The common way to achieve a floating concept is making a hug and building a lightweight house on the top of it. This concept is used in all houseboats where steel or timber hug which will be used as a base to build a house. Floating house project applies amphibious structures designed to practice. In normal condition, the house sits on the ground. When floating occurs, the house rises up and floats on the flood water. The idea of amphibious house gives experience of living on both water and land. In engineering languages, it can be said as a hybrid structure in which the weight of the structure is partially supported by both land and water simultaneously. Due to this, house can be remain close to the ground and retain its original appearance. Under normal circumstances, but to rise with water and floats on its surface when floods occur. Then settle back to its original position at the water level decreases. Various materials can be used for the construction of the structure like lightweight materials such as polystyrene, precast blocks with ferro cement, movable rollers, prefabricated materials, etc. Modular houses are the great alternative to traditional on-site new construction. The possibilities of BIM authoring tools or BIM technology is widely used in prefabrication or modular system. Standardization of a residence system is being widely implemented in eco sector. This is the figure showing floating of a house on water when the water level rises. This also shows the same. Then the basic principle. The basic principle is the Archimedes law. It states that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged is equal to the weight of the fluid that the body displaces. That is, if a body is immersed in water, it experiences an upward buoyant force which will be equal to the weight of the water displaced by the body. The figure shows it. So the net force acting in the body will be the difference of the buoyant force and the self weight of the body. If this net force is positive, then the object will float on the surface of the water. If this net force is negative, then the object will sink in water. So the net upward buoyant force in the foundation should be more than that of the self weight of the foundation plus weight of the superstructure. Then component parts of the floating homes. Similar to all other conventional houses, the floating homes also have three major parts including foundation, superstructure and roof. But the design and methods of construction is entirely different from normal construction methods. The selection of materials for these homes also make it diverse from other structures. This shows a representation of a modular building in an exploded way. Then about the material selection. Conventional concrete and other such materials are not suitable for the construction of flood-resistant house. This is because these materials are heavy and hence contribute to the dead load of the superstructure. So the selection of the material is very crucial in the construction of a floating house. In addition to the self-weight of the material, its durability, cost, eco-friendliness, etc. is also to be analyzed. These are some of the materials chosen. Fiber cement board for the construction of floor, walls, etc. Light gauge steel for the construction of superstructure. Plastic drums for foundations. Marble tiles for flooring. Aluminum sheets for roofing. Then the foundation of the floating homes. The foundation of floating homes is called as buoyant foundation. A buoyant foundation is a type of amphibious foundation in which an existing structure is retrofitted to allow it to float up to a certain height during floods while remaining on the ground in normal conditions. The system consists of three basic elements: buoyancy blocks underneath the house that provide flotation, vertical guideposts that prevent the house from lateral movements, and a structural subframe that ties everything together. Any house that can be elevated were made amphibious, and it will provide low impact flood mitigation strategies for at-risk buildings. Flotation systems being used include log floats, solid styrofoam encased in rubber, foam-filled steel pontoons, concrete and foam, wood and foam, polyethylene shell with solid core polystyrene block molded inside, glass, fiberglass, etc. When the water level rises during flood, it will rise due to the pressure exerted by the rising water. The total built-up area and the weight from the superstructure decides the quantity of flotation material required for the construction of floating house. They are bonded together by steel sections according to the size of the rooms. The rising flotation material will then touches the steel frame below the floor of the house and then the structure rises. Four pillars are driven to the ground on all the four corners of the building, and it acts as a vertical guidepost that prevent the house from lateral movements. These pillars are arranged with a pillar welded inside the pile with its bottom which extends up to the top of the building. These piles will help the structure to remain in its position when the flood level decreases gradually. Intermediate columns of short depth are also provided for added structural stability. Beyond this is structural subframes connecting everything together, including the four major pillars, are constructed when the building rests during the normal cases, where there is no flood water. Human access to the foundation is provided in order to facilitate cleaning and maintenance work. Unlike the conventional houses, the septic tank is also designed to float up to a certain height at the time of flooding. Usage of flexible pipes avoids the chances of damage of the pipelines or fittings. Foundation design. As compared to the conventional houses, the foundation design and construction of floating house is different. A floating foundation is a type of foundation constructed by excavating the soil in such a way that weight of the structure built on the soil is nearly equal to the total weight of the soil excavated from the ground, including the weight of the water in the soil before the construction of structure. In no-flood condition, the floating house will act like a conventional building, which is resting on four piles provided at the each corners. The pile provided is hollow steel pipe. When the flood water lowers or during no-flood condition, the house will fully rest on the steel frame and the load is then transmitted to the pile and then into the ground. During heavy and continuous rain, there is a chance of flooding and this floodwater enters into the excavated portion of the floating house. So the rising water level in the excavation makes the flotation material to rise upward due to the pressure exerted by the entering water, and this may cause the upward movement of the building during flood. In the same way, when the water level decreases, the extended pressure will be reduced and the floating house will come back slowly to its normal position. During this time, the building is resting on a steel frame connecting four load-carrying piles at four corners. Inside each pile, a pillar is constructed which extends up to the top of the building and helps in resisting the lateral movement of the structure without overturning or tilting. Then about the superstructure. The walls were made up of light gauge steel sandwiched between the fiber, cement board, multi-wood or bison panels, etc. Doors and window panels are also made with the light gauge or any other steel sections. Materials are of low cost and are lightweight. All areas of greater weight are centrally positioned. The figure shows the amphibious house in Mesambumel in the Netherlands. Flood resilient infrastructure development and the implementation is important to Dutch culture since the Netherlands has a long history of flood damage mitigation and flood risk adaptation with 60% of the country below sea level. The concept of amphibious house is developed in the Netherlands as Room for the River program. The first amphibious house has been developed in 2015. The project is in the flood zone along the Maas River. The objective of the project was to test the amphibious house in a real environment and demonstrate an approach in comparison with the conventional flood resilient infrastructure. The project is successful in terms of resident satisfaction, international attention, and awards. Later amphibious projects of Jura Vermeer, Factor Architecture and Boyton, and my mitigation measures international potential. However, the project was considered a recreational house that families cannot live there all year round. This is also an amphibious house in Thailand. Severe flooding occurred in 2011 in Thailand and it spread throughout the northern, northeastern and central provinces of Thailand as well as some part of the capital city of Bangkok. It was caused by the three major factors, that is increased fall, topography of the region and the land use that locates in former floodplains and flood-prone areas. After the floods, more construction projects are returning to use traditional structures such as sills and building on barges and rafts. This is also a floating house constructed in Kerala. at Varapalli. Building Information Modeling BIM. It is a process that begins with the creation of an intelligent 3D model and enables document management, coordination, and simulation during the entire lifecycle of a project. The main stages of a BIM lifecycle are plan, design, build, operation, and maintenance. Then the BIM benefits in the design phase. The key benefit of BIM during the design phase is allowing the project team to make any changes to the project at any time, which is very time consuming in traditional methods. By using BIM, various design alternatives can be evaluated and the most efficient design can be selected. Since the team members can communicate remotely, there is no need to meet with each other when collaboration is required. Also, all critical information is available, allowing members of the design team to make decisions more efficiently. Since changes can be made at any time, the members can spend more time on the design to ensure that it will be efficient and appropriate for the intended purpose. After changes are made in some part of the project, all other related parts are modified automatically. This is not the case in traditional design methods in which all related parts must be modified manually, which is very time consuming. Since the entire project can be visualized, the entire project can be investigated, resulting in increased performance of the finished product. Using BIM will improve the project's design by reducing errors. Then about the BIM workflow. Develop the concept of modular residential units. A standardized modular residential unit will be developed and modeled using BIM modeling tools. You have to complete the architectural and structural model using BIM softwares, and after that, we will be designing the floating foundation that aid the buoyancy effect to float the modular system when the floating occurs, and after that, most importantly, we will be preventing design documentation sets. And the BIM authoring tools which can be used for these workflow are Autodesk Revit, StartPro, and ETABS. The architecture model can be created on the Revit software and the figure shows the same. And also the Revit model, the structural model can also be built using the Revit software. And the analysis of the model can be done on either StartPro or ETABS. Then about the benefits. Save lives and minimize property loss. A flood-resistant residential building will be a lifesaver as residents will be protected from the rising floodwaters. A flood-resistant building is specially designed to withstand erosion and the pressure of flowing floodwaters. This will ensure that the building remains intact and does not develop any cracks or other structural issues. A shelter for the standard. A flood-resistant residential apartment can be used as a temporary shelter for outside people who may be stranded or those that may have lost their homes in the floods. They could stay in the apartment complex till emergency teams come to rescue them. The same can be applicable for stranded animals and also such as cats, dogs, etc. Quick recovery. Since people's homes in a flood-resistant building will remain protected from the flood waters, they can recover quickly after the floods. Their belongings will remain safe and there won't be any financial loss. As soon as the roads and the neighborhood are cleaned by authorities, residents can be back with their daily routine without worrying about the losses or experiencing any distress. Long life. A flood-resistant residence is built to last as it has a quantity of construction. It will ensure that it lasts longer than standard buildings. This will significantly reduce the cost of maintenance over the years. The materials are selected by considering these features. Most of the materials are non-corrosive and capable of resisting cracks, fires, etc. Conclusion. Amphibious buildings are a proven low-cost, low-impact flood protection strategy that gives a community enhanced flood resilience and improves its ability to recover from disaster. When flooding occurs, the water dwelling vertically rises with the water level to remain safely above water, then settle back into place as the water recedes. Amphibious construction throughout a new, though it is a new concept, has been growing popularly over the past decade. The implementation of buoyant foundation as both retrofit and new construction would provide benefit to communities at higher risk of chronic flooding. Amphibious construction is a low-impact hurricane mitigation strategy that provides flood protection without increasing exposure to strong winds. It is an innovative approach that is rapidly gaining acceptance and finding application around the world. Amphibious foundations are a proven low-cost and low-impact flood protection strategy. There is a feedback form. I will attach that on the chat box. Please fill it. There will be a BIM Labs workshop on floating modular homes or amphibious homes using BIM. It will be a 3-day, 3-hour session and it will be from 28th to 30th December and its fees is 1500 per head. And the next talk will be on bridges in BIM, conceptual or design, detailed modeling, analysis and design by Mrs. Sujisha B, Assistant Manager. And about the BIM Labs BIM community, there are BIM community links in Facebook, LinkedIn, WhatsApp, Telegram, and Google Classroom. I will attach that on the chat box. Please go through them. Thank you. Have any queries? Thanks for attending.